Good morning, students. In our last class of static electricity, we have seen that when two objects are rubbed against each other, there are certain exchange of electrons takes place between them, and due to friction, static charges are developed in it. The object which is losing electron, due to deficiency of electron, positive charge is generated in it, and the other one which is gaining electron, it has excess of electrons in it, so it contains negative charge. This is how charging takes place using the process of friction. There are two other methods of charging we will discuss in this session. One is conduction and the other one is induction. In the process of conduction, when a negatively charged plastic ruler, as it is shown in the picture, it is actually touching or coming in contact with an uncharged metallic rod, the electrons in the ruler, rather the free electrons in the ruler, travel to the rod. The rod becomes negatively charged by conduction because it accepts electrons from the ruler. During induction, we can see one balloon which is already rubbed with certain object and it is negatively charged. So the negatively charged balloon is brought very close to a metallic beam, but it is not touched. In conduction, it was touched, but in induction, the charged object, the charged balloon was not touched with the uncharged metallic beam. It was brought very close to it. Electrons in the metal are repelled because the balloon has excess of electrons, it is negatively charged. So the negatively charged electrons were repelled and it is accumulated in the far end of the metallic beam. And there are empty places created in the near end of the metallic beam, which is actually depicting positive charge. So these are the three methods of charging we'll discuss. The learning outcome of this part of the chapter will be the students will be able to identify the different parts of a gold leaf electroscope. They will be able to understand the functions of its different parts. They will also be able to understand the functions of gold leaf electroscope as a whole, as an electrical device. They will be able to understand the use of gold leaf electroscope for detection of charge in an unknown object. They will also be able to understand the use of GLE, that is the abbreviation of gold leaf electroscope, for identification of the nature of charge, whether it is positive or negative in an unknown object. They will be able to understand the method of charging by the process of conduction and also the method of charging by the process of induction. They will be able to differentiate between the methods of conduction and induction. Let us discuss about the structure of gold leaf electroscope. You have to learn the drawing of different parts of gold leaf electroscope and the labeling also. This we have already done in our activity class during SAC, so it will be easier for you to practice the diagram. Remember, the labeling is very important here. The gold leaf electroscope consists of a metal, generally brass or copper disc, to which a metal, again brass or copper is used, a metallic rod is attached to the metallic disc. The metallic rod passes into a bell jar through a tightly fitted rubber stopper, which acts as an insulating plug. At the bottom of the metallic rod are mounted two thin strips or leaves of metal. Generally, we are using gold here. The bell jar rests on a wooden base. Tin foil is attached to the side of the bell jar. What are the functions of gold leaf electroscope? Gold leaf electroscope is used for two different purposes. The first one is to detect the presence of electric charge in an object and to identify the nature of charge in a given charged object. Describe how will you use a gold leaf electroscope to detect a charge. Suppose we are given with an object and we have to find out whether the object is containing any charge or not. To detect the presence of charge in the unknown object and to measure the amount of charge present in it, we have to touch the unknown object with the circular brass disc of the gold leaf electroscope. If no divergence is seen in the gold leaves, then the unknown object does not have any charge. And if divergence is seen, that means the gold leaves are moving away from each other, then we can conclude that the object contains charge. The amount of divergence of the leaves is a measure of the amount of charge on the body. If the divergence is more, the object contains more amount of charge. Charging a gold leaf electroscope by the method of conduction. If we want to charge a gold leaf electroscope with a negative charge, we have to touch the brass disc of the gold leaf electroscope with a negatively charged object, maybe an ebonite rod rubbed with cat skin. That's a common example we have done last class, or any other object which is negatively charged. And we have already discussed in the method of conduction, we have to touch the uncharged body with the charged body. So we know that any negatively charged object has excess of free electrons. When we touch the circular brass disc of a gold leaf electroscope with a negatively charged body, as brass is a good conductor of charge, the excess electrons will be transferred from the charged rod to the brass disc and also in turn from the brass disc to the conducting brass rod, and finally these free electrons will be transferred from brass rod to the gold leaves. Because the brass disc, the brass rod and the gold leaves all are interconnected. Now both the gold leaves can contain same kind of charge because both of them are now containing excess of free electrons. Both of them are negatively charged. As we know, like charges repel each other. So the gold leaves having same kind of charge, they will repel each other and we will see a divergence in the gold leaves. That is why in the previous slide we told that if after touching the object with the brass disc, a divergence is seen in the gold leaf, we can conclude that the object has charge. If no divergence is seen, that means the object will not have any charge. Now, let us try to charge a GLE with positive charge by the method of conduction. So, obviously, we know that conduction gives similar kind of charge. So, we have to touch the brass disc with any object which is already positively charged. Let us say think about one glass rod which is rubbed with a silk cloth. It contains positive charge. So we are touching the brass disc of gold leaf electroscope with a glass rod which is rubbed with silk. Now we know that any positively charged object has deficiency of electrons. That means it has empty places which can be occupied by free electrons. The moment it is touched, as brass is a good conductor of charge, the excess electrons will be transferred from the brass disc to the positively charged rod to fill up the deficiency of electrons, and so the deficiency of the electrons will be created in the brass disc. Then the electrons from brass rod will be transferred to the brass disc to fill up the deficiency. In the same way, the free electrons from gold leaves will be transferred to the brass rod. So, finally, a deficiency of electrons is created in the gold leaves, and the gold leaves get positively charged. As like charges repel each other, the gold leaves having same charge repel each other and shows divergence. Describe how you will use a gold leaf electroscope to find the nature of the charge present in a charged object. Now, to test whether a body has a positive or a negative charge, at first we charge the electroscope with a known charge. If the divergence of the leaves increases when the body is touched with the brass disc, then we can say that the charged body has a similar charge as that of the gold leaf electroscope. But if the divergence of the leaves decreases, then we can conclude that the charged object has the opposite kind of charge as it is contained by the gold leaf electroscope. Functions of different parts of a gold leaf electroscope. Brass disc and brass rod. Brass is a good conductor of electric charge, so it can conduct the free electrons through it. Next is rubber or cork lead. Rubber or cork are insulators of charge. So electric charges or the electrons cannot escape from gold leaf electroscope from its top. Why gold leaves are used? Gold is a good conductor of electricity, of course, and it is highly malleable metal. So it can be drawn into very thin sheets. So the sheets which we are using in electroscope, they are very light, having very light mass. So being good conductor of charge, it can conduct charges, and as it is very thin and light, the divergence will be clearly seen. Next is why we are using glass bell jar. Glass is an insulator of electric charge, so the electric charge cannot escape from the side of the gold leaf electroscope. Wooden base. Wood is an insulator of electric charge, so the electric charge cannot escape from below. Tin foil. Tin is a good conductor of electric charge. The charged gold leaves induce opposite charge in the tin foil surrounding it, and the charge remains secured in gold leaf electroscope. Charging a gold leaf electroscope by the method of induction. If we want to charge a gold leaf electroscope with a negative charge, in this case we have to bring an oppositely charged object. So we will be bringing a positively charged object very close to the brass disc of GLE, but we won't touch it. We know that positively charged object has deficiency of electrons. So when the positively charged glass rod is brought very close to the brass disc, then all the free electrons from the gold leaves, brass rod and brass disc gets attracted towards the positive rod. But they cannot be transferred because there is no conducting path. So they get accumulated in the nearer end of the disc. And at the far end of the gold leaves, deficiency of electrons are created. And deficiency of electrons, we have learned in the last class that deficiency of electron means positive charge and excess of electron means negative charge. So in the far end, we can see deficiency of electrons. So in the nearer end, we get negative charge, that is opposite charge, and in the far end, we get same charge or positive charge. If we momentarily touch it, the free electrons will pass from the earth through our body to fill up the deficiency of electrons created at the gold leaves. So now the number of electrons is more than the number of protons in the entire system. If we remove the positive rod now, then the electrons will spread throughout the system uniformly and the whole GLE will be negatively charged. If we want to charge a gold leaf electroscope with a positive charge this time, we have to bring a negatively charged object very close to the brass disc of the GLE, but we won't touch it. Now we know that negatively charged object has excess of electrons. So when a negatively charged ebonite rod is brought very close to the brass disc, then all the free electrons from the brass disc, brass rod and gold leaves gets repelled by the negative rod and gets accumulated in the further end, that means on the gold leaves. And at the nearer end of brass disc, deficiency of electrons is created. So the nearer end gets oppositely charged or positive charge and the far end gets same charge or negative charge. Now we are momentarily touching the brass disc. The free electrons will pass to the earth through our body from the gold leaves. So now the number of electrons is less than the number of protons in the entire system. If we remove the negative rod now, then the deficiency of electrons will spread throughout the system uniformly and the whole GLE will be positively charged. Charging by induction. Now let us try charging a single sphere by induction. When a positively charged balloon is brought near a metallic sphere, which is mounted on an insulating stand, all the free electrons of the sphere gets accumulated in the nearer end of the sphere, leaving behind the empty spaces at the far end. We can see that in the second diagram. So the deficiency of electrons creates positive charge in the far end of the sphere. If we touch the sphere momentarily, the free electrons will pass from the earth to the sphere through our hands to fill up the deficiency of electrons. Now the number of electrons in the sphere is more than the number of protons because some more electrons have come from the earth to the sphere. So this excess of electrons creates negative charge in the sphere. Now we remove the negatively charged balloon from the sphere. So the free electrons will spread over the entire sphere and the sphere will be negatively charged. In the process of induction, the uncharged object always acquires opposite kind of charge. Now, a negatively charged object is brought near to a neutral conducting sphere. The electrons in the sphere are repelled from left side to the right side to the remote end and a deficiency is created in the nearer end. So the nearer end gets positively charged and the far end gets negatively charged. When we are momentarily touching the sphere, the free electrons will pass to the earth through our hand. So if we now remove the negatively charged object from the sphere, so the deficiency or the empty seats for electrons, it will be spread throughout the sphere and the entire sphere will be positively charged. This explains the process of induction clearly. Now let us try charging two spheres by induction. We are taking two metallic spheres A and B which are mounted on two insulating stands and they are touched with each other. When a positively charged balloon is brought very close to sphere A without touching it, all the free electrons from the conducting spheres A and B will be attracted towards the positively charged balloon leaving behind the empty places at the remote end of the sphere B. Due to the deficiency of electrons, positive charge is generated in the remote end of sphere B. Now sphere B is separated from sphere A using insulating stand. When the positively charged balloon is moved away from sphere A, then the accumulated free electrons are distributed uniformly throughout the sphere A and sphere A gets negatively charged. The process of charging by induction always generates opposite charges. Now we are taking two metallic cola cans A and B, and it is mounted on two insulating paper cups and they are touched with each other. When a negatively charged balloon is brought very close to can A without touching it, all the free electrons from the conducting can A and B will be repelled by the negatively charged balloon, leaving behind the empty places at the nearer end of can A. Due to deficiency of electrons, positive charge is generated in the nearer end of can A. Now can B is separated from can A using insulating cups. When the negatively charged balloon is moved away from can A, the accumulated empty spaces with deficiency of electrons are distributed uniformly throughout can A and can K gets positively charged. The process of charging by induction always generates opposite charges. Let us differentiate between the process of conduction and induction. While charging by the process of conduction, as we can see in the figure, the charged object is actually touched with the uncharged object. But in the process of charging by induction, the charged object is brought very close to the uncharged object, but they are not touched. In conduction, the uncharged object acquires same charge, but in induction, the uncharged body acquires opposite kind of charge. Let us try one interesting activity. Those who have seen the movie The Last Airbender, I think you have noticed the water tribe who learned water bending by observing the tidal force exerted by moon. We can also achieve that with the help of static electricity. For this activity, we'll be needing a plastic rod, a piece of cloth, and a running water. What we have to do is we have to rub the surface of rod with the cloth for few seconds. Now we have to turn the tap and steady water will come out. Now we have to put the rod which was rubbed with cloth near the water and we have to observe, and we will see that the water is bending. Now what is the science behind it? When the negatively charged rod approaches the water, it repels the electrons in the water. This gives the water nearest to the rod a positive charge by the process of induction, because induction always gives opposite kind of charge. Now we know unlike charges attract each other. So the attraction between this positive charge and the negatively charged pipe and a net force on the water is seen, and this allows you to bend the water. Critical thinking questions. Question number 1. If gold leaves of an electroscope are replaced by plastic strips and a charged body is brought in contact with the brass disc, what will happen? As we know that plastic is an insulator of electric charge, when we touch the charged body with the brass disc, the free electrons will pass through brass disc and brass rod, but plastic will not conduct charge. So no divergence, no repulsion will be seen in the plastic strips. So the electroscope will not function with a plastic leave. Question number 2. If a charged plastic straw is brought near another uncharged plastic straw, what will happen? Now, when a charged straw is brought near the uncharged straw, due to induction, opposite kind of charge will be generated in the nearer end of the uncharged straw. And as we know, unlike charges attract each other, so they will be attracted to each other. The uncharged straw will be attracted by the charged straw. I hope all of you understood the concept. If you have any doubt, we will clarify those doubts in our Teams class. Thank you, children.